Okay, so today you're going to learn the last section for your Chapter 11 test, which is 11.6, solving rational equations. So basically they're word problems. You're going to have to write an equation to represent the word problem, and then you're going to solve it. So let's try the first example. It says, for each of the following, set up the rational equation and solve. So number 1. Hannah and Michael have been commissioned to restore the Mona Lisa. We're going to help fix it. It takes Hannah 24 weeks to restore the painting, and it takes Michael 40 weeks to restore the painting. How long will it take Hannah and Michael if they work together to restore the painting? So now you have to set up an equation. Okay, so I guess before we do that problem, let me tell you how these problems work. I call them like work problems, because like you're doing some work and your job is to try to finish a job, try to finish something. So the way work problems, I guess the way they work is you're gonna take like the time worked over your rate, and that's gonna equal to like the job done. So like for example, like I guess the same thing here with the Mona Lisa. So like let's say Mrs. Garcia, I'm super fast. Let's say it takes me 10 weeks to restore the Mona Lisa. So like my rate would be 10. Obviously if I work for 10 whole weeks, so if my time worked is 10 and my rate is 10, then I'm gonna do one whole job done, like one Mona Lisa restored. Or again, like if my rate is 10 weeks, but let's say that I only work 5 weeks, so my time worked is only 5, well, that's only going to give me half of the work done, and so on. That's how work problems work. You take the time that you work on it, and you divide it by the rate, and that's going to give you how much of the job you have completed, so job completed. So now, with that little explanation, let's try to do example 1. I already read you the question. So the problem wants to know how long will it take Hannah and Michael to work together to restore this painting. So that's how X is going to be. X is going to be the time worked together. So that's what we're looking for. Like how long is it going to take them to work to finish this job together? So what I'm going to do is first I'm going to do a little fraction for Hannah. Hannah's rate is 24 weeks. So I'm going to put 24 right there. And like I said, if Hannah works 24 weeks all by herself, she'll be done with the painting. But we don't know how long Hannah's going to work if she's going to work with Michael. So here we're going to put X. That's how long. We don't know. We're looking for that. How long is Hannah going to work? So put X over 24. That represents Hannah's fraction of the job that she'll do. Now plus we're going to add Michael because he's going to help. So Michael's rate is 40 weeks. So he can complete the job in 40 weeks. Again, we don't know how long they're going to work, how long he's going to be working, so call it X. And now together, if you add those, that should give you one job done, like one job completed. And that's how you write or set up these rational equations. And on your test next week, you're just going to be setting up the equations as it. So like for your word problems, they're going to be multiple choice, and you're just going to be setting up the equation. So number 1, like that would be your answer. It's multiple choice, select the one that looks right. Today, I'm going to show you how to also solve it. So to solve them, if it was a regular school year, we would be solving these with a calculator. But right now the test is non-calculator, so let me show you how to solve this without the calculator. To solve a rational equation, the first thing you want to do is you want to multiply this equation by the LCD, the least common factor. So here's how you solve. Step 1, multiply by LCD. So again, you're not going to have to solve it on the test. You just have to set it up. But let me just teach you how to solve it anyway. So number one, we need to multiply this equation by the LCD so that I can get rid of the fractions. So the LCD between 24 and 40 is going to be 120. But the way you find the LCD is you start by breaking down your denominators here. For example, you need to find what they have in common, the least common multiple. 24 can be broken down as 8 times 3, and 40 can be broken down as 8 times 5. So my LCD is definitely going to involve an 8, and then it's going to involve the 3 and that 5. So together, if you multiply 8 times 3 times 5, or in other words, 8 times 15, you get 120. So that's how I found the LCD. And now what I'll do is, to solve it, I'm going to multiply this whole equation by the LCD, 120. So like I said, on normal school year, this would be with the calculator, so we would be doing this much quicker. So if you do multiply 120 times x over 24, you're going to get, anybody? 5x. Okay, then if you multiply 120 times x over 40, you're going to get 3x. And then if you multiply 120 times 1, you're going to get 120. And that's a simple linear equation. So you can solve for x very quickly there. 8x equals 120. X equals 15. So once you set up your equation, you want to solve it by multiplying by the LCD like I just did, and then just, I guess, simplify. So it looks like together it will take them 15 weeks. 15 weeks to finish the job together. So Hannah's going to do 15 out of 20, and Michael's going to do 15 out of 40. That's his fraction of the job, and together they're going to finish one job in 15 weeks. I'll pause for questions, and then I'll let you try example 2. See if you can just set it up. All right, so let's try number 2. Read the scenario, and let's try to set up our work equation. It takes Tyler an hour and a half to mow the lawn by himself. That's his rate. So like for Tyler, hour and a half, let's put 90 minutes. I'm going to do it in terms of minutes. You can do it in terms of hours if you like. It takes Josh 45 minutes to mow the same lawn, so he's much faster. So that's his rate over here for Josh. Tyler begins mowing his lawn, and then after 10 seconds, Josh comes over to help. How long did it take to mow the lawn together? So again, I always like to start with like x equals time worked together. So when you set up your equation, the numerator should be the time worked, and then the denominator should be the rate. So like I was saying, this is Tyler, and this one's Josh. So Tyler's rate is 90 minutes, so that's what I'm going to put down here. Tyler began mowing the lawn, so that's how long, X is going to be how long, I guess, Tyler worked. And now when you do Josh over here, we can't just put X because Josh didn't work the same amount as Tyler. So, for Josh's time right here, it says that he came over to help 10 minutes later. So for his time worked here, we're going to go ahead and put X minus 10 because, like I just said, Josh worked 10 less minutes. So that's his time to work right there. X minus 10. So I guess this X should be the time that Josh worked, or sorry, Tyler. But that's okay. You just need to set up the equation. So together now, if you add both of those fractions, that should give you equal to 1 because they're just mowing one lawn together. And then that's all you would be expected to do on the test. You would just select that one. And that would be it. For today, why don't we go ahead and just solve it, just for practice. To solve, you're supposed to multiply by the LCD. This one, the LCD is easy. It's 90, because 45 is just a multiple of 90, so you can multiply the whole thing by 90. So if you multiply 90 times x over 90, that's x. If you multiply 90 times x minus 10 over 45, that's going to be 2 times x minus 10. And then if you multiply 90 times 1, that's just 90. Again, that's just a simple linear equation. You can solve that and get x. 3x equals 110. 3x equals 110. X equals 110 over 3 minutes. So now, to answer the question, I guess, how long did it take to mow the lawn? That's how long it took to mow the lawn. It took about, I don't know what that is. That's like about 36 minutes. So it took about 36 minutes to mow the lawn, and that's how long Tyler worked. He worked the whole 36 minutes. Josh only worked 26 minutes, but the question just said how long did it take to mow the lawn, so you would just go with about 36 minutes. That's how long it took to mow the lawn. Time to mow lawn. So X is the time to mow lawn. That was problem number 2. I'll pause for questions. Okay, so now let's do number 3. Number 3. A swimming pool can be filled using either a pipe or a hose, or both. Using the pipe alone, it takes 12 hours, I guess, to fill the pool. Using both the pipe and the hose, it takes 8 hours to fill the pool. How long does it take using the hose alone? So this time we're solving for something else. How long does it take the hose alone? So you're actually solving for like the rate of the hose alone. X equals the rate of hose alone. So some of your X is going to be on the, will be in a different location. So here, let's try to do it. We have a pipe and we have a hose. Together, we need some kind of fractions, and together they're going to equal to filling one pool. This time the question tells you how long it takes both of them together to fill the pool. It says that it takes them 8 hours. So here at the top, I'm going to put the 8 hours because that's how much time they would have to work together to fill the one pool. So at the top, that's how much time they have to work. So like the time worked, it'll be 8 hours. On the denominator, you want to put the rate of each item. So for the pipe alone, its rate is that it can fill the pool in 12 hours. So that would be its rate right here. So the pipe is going to fill 8/12 of the pool. Plus, now you're looking for how long it's going to take the hose to fill the pool. So that's what your X is. We don't know what that is. And that's what you're solving for now. And for these, you're going to have to just practice them with your math, with your online Math Excel homework. Practice setting those up. And I think you might need the calculator for the homework, so just use it to make it speed up. But on the test, that's all you're expected to do right here. Just set up this equation. So that would be it. For now, let's practice solving it. The way you would solve these rational equations is to multiply by the LCD. The LCD here is going to be 12x. So let's multiply this thing by 12x. 12x times 8 over 12 is 8x. 12x plus 12x times 8 over x is 12 times 8, 96. 12x times 1, 12x. Solve for x, that's just a linear equation. 96 equals 4x. 96 divided by 4, 24. So the rate of the hose alone is 24 hours. And that's how I would answer the question. Number 3. Let's try it one more time with example 4. So these are what I call like work problems. So the jobs that you complete is equal to how much time you worked over your rate of doing a job. So try example 4, read it, and try to set up an equation. Okay, number 4. Hopefully you read the scenario, but the question wants to know at what time did the printing presses complete the order. So X is going to be like the time printing. So maybe it takes 2 hours, 3 hours, 4 hours, I don't know. But we are going to let X be the time printing since 1 p.m. because that's when the first machine started. Time printing since 1 p.m. or from 1 p.m. So then here's how I'm going to set up the equation. We have 2 machines, the model 4500 and then we have the model 6000. So the 2 machines, it says the model 4500 can print the 10,000 booklets in 4 hours. So this 10,000 booklets, you don't have to really literally use 10,000. We can just think of that as like one job done. Same thing with the other one, like it does 10,000 booklets. So that's just going to be like one complete job done. So for the model 4500, at the top you have to put how long it works, and at the bottom you have to put its rate. So 4500 can do the job in 4 hours, so that's its rate. And we don't know how long it's going to work, so that's what we're going to call X. And then, actually, yeah, let's call it X, even though it's going to be from 1 p.m. I'll fix that. Okay, let's do the model 6000. Model 6000 can also do the one job of 10,000 booklets in 6 hours. And then we don't know how long that's going to work, so we can call it X. But both of those do not work the whole time, so who gets turned on? Let's see. The model 6000 began printing at 1 o'clock, so let's let that one be X. Because the company called and needed to pick up the order before 5, model 4500 was also turned at 2 o'clock. So for the model 4500, I'm going to go ahead and subtract 1 from it. Because if you read the scenario, that one didn't start working until 2 o'clock. So this is one correct possibility to set this up. And then just like someone asked earlier, there is another correct possibility if you want to put the X over here on for the model 4500, you could put X here, and then on this guy, you could put X plus 1. Either one would be correct. Since you're only setting it up, that would be one of the answer choices. Like I said, I won't put both answer choices since they could both be correct. So this is one correct choice. So that's how you would set up the equation. Now you need to solve it. So you would solve by multiplying this by the LCD. So the LCD between 4 and 6 is probably 12. Yeah. Multiply the whole thing by 12. 12 times x minus 1 over 4 is going to be 3x minus 1. 12 times x over 6 is going to be 2x. 12 times 1 is going to be 12. Just solve. 39? No, that's not right. What did I do wrong? Oh, 15. You have to add the 3 to the 12. So once you set up an equation, you're supposed to solve, and now you need to answer the question, because the question is asking you at what time did they complete the order. So X is the number of hours, I guess, has been working since 1 o'clock. So if it took them 3 hours since 1 o'clock, that means that they're going to finish the job at 4 p.m. Job finished at 4 p.m. because I did 1 plus 3. So that would be the final answer. So again, these questions are called work problems. You're going to have to practice them. And on the numerator, you put the time that you worked. And on the denominator, you put your rate. And that should give you how much of the job you've completed. Practice. So now the back of today's examples, they're still work problems, but now these are what I call distance problems. Okay. So all of these will be a distance kind of question, and you'll definitely will have one of these on the test as well, where you're just setting it up. So what you need to know about distance, I don't know where you learn this, like middle school science or physics, I don't know, but the distance that you travel is equal to the rate at which you're moving times the time that you traveled that. So like if I drive 50 miles per hour for a whole hour, then I'm going to travel 50 miles. So that's what you need to know for these kind of questions. Now let's read the scenario. Number 5. Lucy canoes 15 miles upstream, so that's going to be a distance, and then back, in twice the time it takes her to go 27 miles in still water. So up the stream means like she's going to be fighting a current. Down the stream means she's going to be going faster with the current. Still water just means there was no current. The rate of the current is 2 miles per hour. Now find Lucy's rate in still water. So first of all, let's let X equal with the question. Find Lucy's rate in still water. Lucy's rate in still water. Okay, so now here's how you set these up. I like to set these up with like a little chart, which I call the distance, rate, and time chart. We're going to divide her trip into upstream, downstream, and still water. So right here, let me talk about upstream. So let's start with that. When she's going up the stream, she's going to travel 15 miles. So that's my distance, 15 miles. Equals. The rate that she's traveling at up the stream is going to be something to do with X. It's going to be the rate in still water minus 2. And let me explain to you why is X minus 2. So the rate, her rate up the stream is going to be whatever the rate is in still water, so X, minus the current. Because when you go up the stream, you're fighting the current, so you're going slower. So we're going to call this X minus 2. Now her time up the stream, this is tricky, but I'll tell you what it is. Her time up, and then I'll explain it. Her time up the stream, basically what I'm going to do, I'm just going to move this X minus 2 and divide it on the other side, and this is going to be 15 over X minus 2. Write it down first, and then let's analyze it and see why is it right. I'll pause for. So here's my first equation. It's going to be up the stream, 15 equals X minus 2 times 15 over X minus 2. The reason why this is 15 over X minus 2 is because if you multiply 15 over X minus 2 times this X minus 2, those cancel out and you're left with 15, which is correct. And that equation represents Lucy's trip going upstream. Okay, now let's represent Lucy's trip going downstream. Here goes. Downstream, she's still going to travel a distance of 15 miles because she went up and down the stream. Same distance, 15 miles. Her rate going down the stream, kind of like, wait, Seth just mentioned earlier, is going to now be x plus 2, because when she's going down the stream, she is going to go faster. The current, which is 2 miles per hour, is going to be helping her, so plus 2 miles per hour. Okay, now you figure out what is the time right here. The time is going to be a rational expression. So it needs to be 15 over x plus 2. Because if you multiply 15 over x plus 2 times the x plus 2, you'll get the 15. And that represents her trip down the stream. Finally, we got one more. We need to represent her, I guess we need to represent her information if she was to go in still water. Still water means there was no current. And here's what that question says. It says, okay, it takes her, she can go 27 miles in still water in the same amount of time that she went up and down the stream or whatever. But let me just do this information. 27 miles in still water. So the distance is 27 miles. The rate in still water would just be x because there was no current. And finally, her time for this scenario should just be the, it should be something over something. It needs to be a fraction. It's going to be 27 over x. And now that information represents her a trip in still water. Okay, now after all of that, we haven't even had the actual equation yet. So the actual rational equation that you're going to write, rational equations are fractions. They require like a numerator with a denominator. The rational equations will always be the time, because time is the only thing here that's a fraction. So here's what we're going to do. We're going to write our rational equation with time. Rational equation with time. So here's how it looks like. I guess I'll write it with words first, and then we'll do it with the actual fraction. But it says Lucy can go 15 miles up the stream and back in twice the time it takes her to go 27 miles in still water. So like if I write those English words into a little equation, it would be the time up plus the time down equals twice the time in still water. So this is me trying to teach you how to write the equation. So now you're going to have to think about your data here and write me the actual rational equation that says the time going up plus the time going down should equal to 2 times her time in still water. So you get a minute to try to come up with the actual equation here. Go. I hope you tried it, but so on the test, I'm going to ask you to just set up the equation for this problem. So your answer would just be the equation. So here's, n is multiple choice, so select the one that looks right. But your equation will be this. It would be the time up, so 15 over x minus 2, plus the time down, 15 over x plus 2, equals twice as much time in still water. So now that would be your answer. Is multiple choice selected. So all this information over here that we did, that was just to help you get to that answer right there. So that's all you're expected to do for the test because we're not using a calculator. In regular years, we would just put this in the calculator and solve it. But on my answer key, I did go ahead and solve the equation by multiplying by the LCD. And I guess we can try to do it right now. I think we will have time. If you were to try to solve this equation, you first need to multiply by the LCD like I've been doing. So the LCD between these fractions is going to be an x minus 2 times an x plus 2 times an x. And then I guess if you recall the 11.5 when you're trying to find the LCD, you do what I just did, x minus 2, x plus 2, and x. So if I were to try to solve this, we would have to multiply this whole thing by the LCD. Okay, let's just do it. So let's multiply by x minus 2, x plus 2, and x. So if I multiply 15 over x minus 2 times the LCD, I'm going to get 15 for sure, x, and x plus 2, since the x minus 2's will cancel. Next, if I multiply 15 over x plus 2 times the LCD, I'm going to get a 15x, x minus 2, since the x plus 2's will cancel. Equal, if I multiply 2 times 27, I think that's just 54. So if I multiply 54 over x times the LCD, I'm going to get 54 times x minus 2, x plus 2. So this looks complicated, but it's not that bad. Once you simplify everything, it's a nice, easy quadratic that simplifies into nice integer answers. So I can do it. I'm going to run out of space. I can just do it over here. 15x squared plus 30x plus another 15x squared minus 30x equals 54 times x squared minus 4. I'm just trying to simplify this mess. This is just a 15x squared equals, nope, it's not 15x squared, 30x squared equals, 15 plus 15 is 30. The 30x minus the 30x cancel. So I got 30x squared equals 54x squared minus 54 times 4, 216. And now, like I said, this is a quadratic, so let's set it equal to 0 to solve. 24x squared minus 216. I'm going to guess that I can factor a 24 to that. So 216, take out a 24. I think it's 9? 19, 20, yeah, 9. Okay, so finally, after all of this, I can get an answer. Set each factor equal to 0, so x equals 3, x equals negative 3. The whole question was, what was the rate in still water? So what is x? Obviously, x can't be negative. You can't have a negative rate for still water. So we're going to go with x is 3 miles per hour. Okay, so that was just all for fun. On your test, you're just going to have to tell me the equation. And this is how you do a distance problem. You need to set up your distance equals rate times time. So let's try it again on number 6. I'll pause for a question. So number 6. It's another distance problem because it involves distance, rate, and time. So distance equals rate times time. James drove halfway from his house to the mall at 40 kilometers per hour. So that's some kind of rate. At what speed must he drive the rest of the way in order to average 30 kilometers for the whole trip? So I guess if you have another way of doing this, go ahead and do it your own way, but this is what I do. I'm going to divide his trip into sections. The first section is halfway, so the first half. Then you're going to be looking for the second half of the trip. And then we're also going to have the total part. Well, let's just start with this. So here it goes. What is x? At what speed must he drive the rest, so the second half of the way, in order to average the speed? So x equals the rate for the second half. So right here, for our second half, we're going to have to use and involve this x. First, we can start with the first half. So on the first half, James drove halfway to his house at a rate of 20 kilometers per hour. So this rate would be 20 kilometers per hour. Now the problem with this question is, like, we don't know the distance. But it actually won't matter because it says that it's halfway. So for this distance right here, let me just call it d over 2. I'm calling it d over 2 because whatever the distance was, so d could be 100 or 10 or whatever. If you just divide it by 2, that represents the distance on the first half. So d over 2 equals 20, because that's his rate, times time. Now try to figure out what this has to be so that when you multiply it by 20, it's going to give you d over 2. So the time is going to have to be d over 2 over 20, because if you multiply that by 20, you end up getting d over 2. I will simplify that better, but for now that's how you can express it. Next, for the second half of the trip, the distance would be the other half, so you would still write it as d over 2 for the other half. The rate for the second half of the trip is unknown. That's what you're looking for. X is the rate for the second half of the trip. So now here, you figure out what fraction has to go here so that when you multiply it by x, you'll get d over 2. It's going to be d over 2 over x. Because if you multiply d over 2 over x times x, you get d over 2. And finally, like I was trying to tell you, we need another row here for this little table that I'm trying to make. And that other row is going to involve the information you know for the whole trip. So the question says that he averaged 30 kilometers per hour for the whole trip. So that was his rate for the whole trip. So here, let's put whole trip. So for the whole trip, his distance is no longer going to be d over 2. His distance is going to be d. Even though, like I said, we don't know what that is, and at the end it actually is irrelevant. It's just going to be d. The rate that he traveled for the whole trip is 30 miles per hour, or 30 kilometers per hour. So now again, you have to figure out right here. 30 times what would give you just d? D over 30. And now finally, you have to set up the real equation. The real equation for these kind of problems involves a rational equation. So the only thing that's rational here is the time. So your equation always has to deal with time. So you need to have your rational equation. So rat equation with time. So for this one, it doesn't give you specifics about the time, but like if you just think common sense, the first half of the trip plus however long it took him for the second half of the trip should equal to the total time of the trip. So you write your equation here that says the time for the first half plus the time for the second half should equal to the time on the whole trip. Hopefully you're about to write d over 20, d over 2 over 20 plus d over 2 over x equals the d over 30. So instead of putting d over 2 over 20, let me simplify this. This would be d over 40. So the time for the first half plus d over 2x plus the time during the second half together should add up to the time for the whole trip. And now that's the equation. So that would be your answer. And actually, we're going to simplify this a little bit because notice how you do have two variables, the d and the x, and that can't happen. You can only have one variable. But because the d is on the numerator for all of those fractions, then it would just cancel out. Like the d will just go away and cancels each other out. So the correct actual equation should actually be 1 over 40 plus 1 over 2x equals 1 over 30. So let's not box that one. This would be the actual correct equation. That's the correct equation. That's all you would be expected to do on the test. You're just setting it up. For now, I can solve it because this one's not that bad. So to solve this one, we'll do what I was trying to do the whole day. Just try to solve an equation, you have to multiply by the LCD and simplify. So let's do that one. And then I'm going to run out of time so you can finish example 7 by yourself. I'll make the video for you if you want me to, and you can come watch example 7. But basically, example 7, you're just solving it. And it's going to look very, very similar to example 5. Like this whole mess that I made here, that's going to be example 7. But I'll make you the video if you like watching videos. Anyway, let's finish this one. So to solve this equation, multiply by the LCD. Okay, then what's the LCD here? 40, 2x, and 30. Because of the 40 and the 30, okay, any help is appreciated here, but 40 and 30, 120? We're going to need at least a 120. And then the 2 is already part of the 120, so we're good. And then x. Okay, so I think the LCD is going to be 120x. So let's multiply the whole thing by 120x. 120x times 1 over 40. (3x) plus 120x times 1 over 2x. 60 equals 120x times 1 over 30. For x. And solve for x. That one's much easier. 60. So to answer the question, it looks like James traveled at 60 kilometers per hour during the second half of his trip. And that is how you solve rational equations with word problems. You just have to set them up. And now you need to practice example 7 by yourself. Good luck. Okay, so to finish today's examples, number 7 is very similar to problem number 5 since I already solved it there. But we can just do it again. The way you solve any of these rational equations is you first want to multiply by the LCD. So you need to be able to identify the LCD here, which based on if I factor this, it looks like the LCD is going to be x minus 1 times x plus 1. So that's what I'm going to multiply this thing by. So if I multiply the first fraction by the LCD, everything will cancel except for the 10. If I multiply the second fraction by the LCD, the x minus 1 will cancel, but I'll have 2x minus 5 times an x plus 1. And then finally, if I multiply this last fraction by the LCD, you'll have 2x plus 5 times x minus 1. So that's step 1, multiply by the LCD. Now you've got to simplify everything. If I simplify everything here, I've got 10 plus 2x squared plus 2x minus 5x, so minus 3x minus 5. And this side is 2x squared minus 2x plus 5x, so plus 3x minus 5. And now I'm just going to try to set this equation equal to 0. So I'm going to move everything to the right. 2x cancels. Minus 3x plus 3x is 6x. Minus 5 plus 5 cancels. Positive 10 over minus 10. So, oh, that seems much easier than example 5. Solve for x. 10 equals 6x, so x equals 5/3. Oh, that was perfect. X equals 5/3. One thing I forgot to mention about the other problems was like the restrictions on the variables. So like on, because it didn't ask for that on those word problems, but here it does ask for the restrictions. So just like we did earlier on section 11.5, the restrictions just means that your denominators cannot equal to 0. So your restrictions here would be x can't equal to 1 and x can't equal to -1. So that would be your restrictions. And that's it for this problem. Sometimes you have to be careful when you're solving just these regular problems, because sometimes your solution would be the restriction and therefore you would have no solution. So for example, like suppose you solve this, and if you end up solving this and you get your answer to be like x equals 1, if your solution is one of the restrictions, then that means that you can't really have x equals 1. So in that case, like you would have a no solution kind of problem. So practice the homework to make sure you you notice what I'm talking about. But for now, it's just our answer was x equals 5/3, and these were the restrictions. X can't equal to 1, and x can't equal to -1. Now go do and practice some homework.